let's go over the test you took in class last time. You can retake this test starting today after school, and you have all of next week. Makeup tests are due by Friday. Number 1, which statement is true about the graphs of these equations? If you do not remember anything about parallel and perpendicular as far as looking at the equations, please graph it in the calculator. So that's what I'm going to do. Escape. Control Doc. I'm going to add a graph and graph it. 6x plus 4. Down arrow. 5x minus 2. Okay. A couple of choices. Some of you graphed this and said that these are parallel. I want to zoom out. Now I understand why so many people picked parallel. Parallel means the slopes are the same. And my slopes are not the same. So these lines cannot be parallel. But let me show you how on the calculator that they're not parallel. You press menu, go down to zoom, and you need to see a bigger shot of this picture. So enter, and now we need to zoom out. Now once I press enter, I'm just going to continue to press enter until I can see for sure that they're parallel. And I don't know if you can tell or not, but right down here at the bottom of the screen, they intersect. Which means, can the calculator save you every time? No. This is one of those questions where you needed to know that for parallel lines, the slopes must match. And they don't. M is 6, M is 5. That's two different numbers. They don't match. They cannot be parallel. To be perpendicular, they have to be a 90-degree angle. If we go to our calculator, I don't think that's 90, do you? 90 would be if I drew another line about like that to make a perfect L. So no, they're not perpendicular. Now I did see two lines, so it wasn't the same line. I know they intersect, it just wasn't at a 90-degree angle. Number 2, which statement describes a line whose equations are y equals 1/3 x plus 12 and 6x equals 2x plus 6. Okay, so a lot of you saw their segments and automatically eliminated that. To be a segment means to stop, meaning it doesn't keep going. So it's not A. B, they are perpendicular to each other. Okay, well let's check their slopes. This one you had to do by hand. Somebody tried to move 2x by putting a minus 2x under it. 2x is already where it needs to be. So the only thing you're going to do in this problem is divide by 6. So y equals 1/3 x plus 1. Somebody else left it 2 over 6 and did not reduce it to this. So they didn't see that these were alike. So make sure you're simplifying. You could have typed 2 divided by 6 in the calculator. It gives you 1/3. So the slopes are the same. That means they're parallel. Number 3. Which is an equation of a line parallel to the line whose equation is 3y equals 2x plus 3. It wants parallel. So the 2x is already on a different side of the equal sign than the y. So the only thing you need to do is move what's by the y, which is the 3. So we divide. When we divide, the 3 goes away. I'm left with 2/3. To be parallel means the same, so which down here has a slope of 2/3? That has a slope of 3/2, so that is definitely not the answer. This one is not solved, so if I divide it by 3, now I see the slope, because that cancels. It's negative 2/3. I have a positive 2/3. That's not the answer. Over here, I divide by 2, I see 3/2. And it is not the same as 2/3. Well, there it is. It was already solved for y. It looks just like the slope I found. The answer was B. Number 4. Look at the system of equations below. Y equals 3x minus 2, 2y equals 6x minus 4. Which of these describe this situation, or this system? Okay, so I want to know, are they parallel? Are they the same line? And when it says same line, it means, do they look like this? Meaning, are they infinite solutions? Are they infinite solutions? That's what it means. Parallel means, do they do this and not cross? That's what you thought you saw on number 1. But the slopes aren't the same. There's no way those could be parallel. So you had to zoom out on the calculator to see that they would cross. Do they intersect at this point? Do they intersect at this point? So let's first put them in y equals form. Divide by 2. The x is already the x is already on a different side from the y, and the only thing by y is 2. So I need to divide off 2. That leaves me with, and somebody did this but didn't reduce, so they didn't see that they were alike. 6 divided by 2 is 3. That's 3x minus 2. So now this matches that. These are parallel. That's what a parallel looks like. That's why number 1 is not parallel. 3 and 3, parallel. 6 and 5, not parallel. What is the slope of a line that is perpendicular to this equation? So we need the slope, which means we move the 2x. Because you see how this y and this 2x are on the same side of the equal sign? Look here. This x and this y are not on the same side of the equal sign. So you don't move that 2x. But you have to move this one. And that gives us y equals 2x plus 5. So my slope is 2. Now, which slope is perpendicular to that? Well, this one's parallel. Okay. And if this is positive, my slope needs to be negative. Well, that's positive. So I'm left with these two. They're both negative. How do I know which one's the answer? Well, you have to also flip it. That's not flipped. It looks just like him. So this is the answer. How did they get it? They put this over 1, turn it upside down. Number 6. What are the slope M and the y-intercept B of the line passing through these 2 points? Okay, that is menu 613. Scoot it over so you can see. Control Doc, add a calculator, menu 613, control brackets, -3, comma 7, 1, comma -5. I'm going to check my work. -3 is an x, 7 is an x. Good. Now go back and start with the point you started with for the last one. So now I put 1 and then -5. Okay. Enter, enter. I don't like the way this looks. I'm going to change it to a fraction. Menu 2, 2. Negative 3 over 5 is the slope. No, no. So it's A and D. Negative 4/5 is the B. There is the answer. Okay, on the next video, I'll start on the next page.